Okay, so today we're going to talk a little bit about physical properties, the differences they have with chemical properties, and at the end we're going to focus on density. So this is part of your study of matter. You better remember, matter is anything that has mass and takes up space. Mass is the amount of matter in something or how much stuff there is. Volume is the amount of space something occupies. So matter has mass and has volume. Takes up space, has stuff in it. So you should be able to answer which of the following is matter: a car, a box, or you. All of those are matter. Okay, remember we said everything except like ideas, emotion, feeling, stuff like that. So a property is a characteristic of a substance that can be observed. So anything that can be observed. Oops, I don't know why I went like that. So physical properties is a property that can be observed without changing the identity of the substance. So examples of physical properties are luster, which is like whether something's shiny or not, malleability, ductility, which are defined right there. Malleability, the ability to be hammered into a thin sheet. So like aluminum is very malleable because it can be made into the sheet of aluminum foil. Ductility is the ability to be stretched into a wire. Gold is very ductile. About 50 years ago, gold used to be one of the key ingredients in braces because that wire that goes across the front needed to be stretched really, really thin and then bend around, making them quite expensive. Melting point and boiling point are physical properties of a substance. When you made your graph, you should have noticed that your graph has a very specific shape. Every substance is going to have a different graph. It's going to boil and melt at different points. So you could identify the substance based on the graph of when it melts and when it boils. Density is a physical property that we're going to look at today. Solubility we'll do a lab on later this week, whether or not a substance can dissolve in another substance, so like sugar and water. And specific heat is another one, which we'll get into later, maybe next week with a lab. So special physical properties. We already looked at these. We already did a lab. So melting point, the temperature at which a substance changes from a solid to a liquid at a given pressure. Water's is 0 degrees Celsius. Boiling point, the temperature at which a substance changes from a liquid to a gas at a given pressure. Again, water's is 100 degrees Celsius. And the boiling point is the same as the condensation point, which is when it goes from a gas to a liquid. Melting point is the same as a freezing point, where it goes from a liquid to a solid. So just the other direction gets new names, but you already have that written down. So opposite of physical properties are chemical properties. Chemical property is a property that can only be observed by changing the identity of the substance. So you're going to change the chemical makeup of it. You're going to rip up some compounds, make new combinations. So rather than like H2O, like when you boil it, it's still H2O. The molecules are just moving apart faster. Maybe you ripped apart those hydrogens and oxygens through electrolysis. That would be a chemical property. Examples of chemical properties include flammability, ability to rust, reactivity with vinegar. So if you put two things together and get something new, then that's an example of something you can observe that's a chemical property. But let's circle back. This is density because that's what we're working on this week. So density is the amount of mass per unit volume. It's the amount of stuff in a given space. Density can be used to identify a substance. All substances have a specific density. Okay, so like gold always has the same density at a certain temperature. The density of water is 1.0 grams per milliliter. Pretty easy to remember. 1 gram per milliliter. So if you have a milliliter of water, it takes up a milliliter of space. You know it has a mass of 1 gram because its density is 1 gram per milliliter. So to calculate density, here's our clicker. Density equals mass over volume, mass divided by volume. So your units are going to be grams per milliliter, or grams per liter, or kilograms per liter. Pick any one of those combinations from the metric conversion, but you got to have grams up here as your base, liters down here as your base. A milliliter and a centimeter cubed can be the same thing for water. Okay, we'll use milliliters more. But a cubic centimeter would be a great thing for like this lab we're doing with the cubes. You're going to measure them in cubic centimeters. So just know that you can change them. Grams per milliliter is the same thing as grams per cubic centimeter. So a cube has a mass of 2.8 grams and occupies a volume of 3.67 milliliters. Would this object float or sink in water? Okay, so you're going to have to do some math. So density equals mass per unit volume. So your mass here is 2.8 grams Your volume is 3.67 milliliters. Okay, so density equals 2.8 grams divided by 3.67 milliliters, which is the same thing as 0.76 grams per milliliter. So now you're like, well, I calculated that, but how do I know whether or not it floats? You've got to remember that the density of water is 1 gram per milliliter. So this object would float because it's less dense than water. Okay? So a liquid has a mass of 25.6 grams and a volume of 31.6 milliliters. So again, your mass, 25.6, your volume, 31.6. You're just going to set up and divide. So density equals 25.6 grams divided by 31.6 milliliters for a density of 0.81 grams per milliliter. Okay, so in both of those examples, we went just find the density. I gave you the mass and the volume, and you found the density. If I give you the density and the volume, you'll be able to find the mass. So a cube has a known density of 2.3 grams per milliliter and occupies a volume of 6 milliliters. What's its mass? So this time you've got a density, 2.3 grams per milliliter, and a volume of 6 milliliters. Density equals mass over volume. Mass is going to equal density times volume. Okay, so if you're in algebra or Common Core 1, if you multiply by volume on this side, multiply by volume on this side, you get this. If not, you can just memorize this, if that makes no sense to you. So mass equals density times volume. We have our mass equal to our density, 2.3, times our volume, 6 is 13.8 grams. Sorry, I went a little faster. 13.8 grams. So the relationships. Density is mass over volume. That means mass equals density times volume, which means volume equals mass divided by density. Okay, you need to know how to work these relationships for calculations. We're going to do a lab. We've probably already started a lab. No, we're going to do a lab with this later, and we're going to spend a day working on the calculations too. So that's it for tonight. Thanks.